Hi, first graders. I'm here today with our warm-up, and we're going to start today by doing our regular warm-up, which is a problem of the day, and then we're going to do our fluency activity. And then for our concept development, you can go ahead to the next video, and we'll keep practicing our double-digit addition strategies. We're learning actually something a little bit new today, so I'm looking forward to it. So our problem of the day, I'm going to read it 2 times, just like I always do. The first time we have to just listen, and the second time you'll start writing your number sentence, and you'll start thinking about how am I going to solve this problem. So our problem is there are 12 chairs right now at the lunch table. There are 15 students that need to sit there. How many more chairs are needed so that every student has a seat? Use the RDW process to solve. And don't forget, RDW stands for read, draw, write. So I'm reading it to you. You will draw and you will write a statement. Okay, so now we've heard the problem once. Let's think about what is my number sentence going to be? What am I trying to figure out? And maybe what strategy am I going to use to solve this problem? So there are 12 chairs right now at the lunch table, but there are 15 students. How many more chairs are needed so that every student has a seat? Use the RDW process to solve. So we've definitely got 2 numbers in there of 12 and 15. I wonder what you're going to do with them. So go ahead and pause your video right now if you want to solve it by yourself. And I'm going to go ahead and solve it here on my whiteboard. Cool, so pause it if you need to. So I know, like I said, there are 12 chairs currently, and there are 15 students that need a chair. So the problem that I'm trying to solve is how many more students, how many more chairs do we need so that every student has a chair? So my 15 is my number of students, so that's actually going to be my total, right? Which means 12 is my part. So, and since I know we need more chairs, or maybe you saw that 15 is greater than 12, however your brain figured that out is awesome. My number sentence to start is going to look like this. 12 plus mystery box equals 15. Now maybe you thought about it a different way, and you thought that there are 15 students total, and we could take away the part that we know, 12, and that will give us the difference or the answer for how much greater 15 is than 12. Either of these 2 number sentences would have been totally great. Okay, now today I get to choose my strategy. I don't have to use a tape diagram or any other specific strategy. So I think for this, I'm going to go ahead and break apart 15 and 12 into their place values, just kind of like we've been practicing. So I broke 15 apart into 10 and 5, and 12 apart into 10 and 2. Now, I know that I already have 10 here, so I'm just going to kind of like cross that out, because 10 minus 10 would equal 0. Any number minus itself would be a 0. And I'm left with 5 take away 2 equals mystery box. Great. Now I happen to know this because I'm a snap fact. If not, I could start at 5 and I could count back 2. So I could go 5, 4, 3, and there would be my answer. It's 3. So I can fill in all of my mystery boxes. 12 plus 3 equals 15. 15 minus 12 equals 3. This is kind of my drawing, my work. And then I need to write my statement. So the question was, how many more chairs are needed so that every student will have a chair? So that means I'm going to have to say 3, and then I have to think, what or who is this problem about? This time it's about chairs. So 3 chairs are needed. Maybe you said 3 more chairs are needed. That would be the most information. Great. Our next game, you can go ahead and put down your pencil and paper or whatever you were using to solve that problem. I'm going to put down my erase board and my marker because fluency games are all in your head. So we are going to play Take Out Some for our fluency game today. So for this fluency game, I'm going to tell you a number, and I'm also going to tell you how much we're going to take out of that number or what part we already know. And then you're going to find out how much would be left in that number. So if you are better at kind of like visualizing number bonds in your head, you can do that. If you want to visualize like a number path or a number line, that's great. Or maybe you'll just kind of know these things like in a snap. And then that's great too. So our first number, and there's a pattern. So I want to see if you can be a really great mathematician and notice my pattern in the numbers. Okay, so we're going to start by taking out 1, just 1. And my first number is going to be 8. So 8, take away or take out 1 is 7. Good job. Okay, my next number is going to be 18. I wonder how the last number could help us. So 18, take away 1 is 17. Good job. Do you see how they're kind of related yet? Okay, if not, here's another example. My next number is 28. So 28, take away 1 is 27. Yes. Okay. Did you see how I was just having the same kind of number in the ones place, but then I was putting a different amount of 10s at the first, and this time they all went up by 10 each time. So if you know 8 take away 1 is 7, then you knew 18 take away 1 is 17, and 28 take away 1 would be 27. They're all sort of related. Whew. Okay, now we're going to do the same thing, see if my pattern stays the same or if it changes. But this time we're going to take out 2. Okay, so the number we're going to take away is 2. Our first total is going to be 5. So 5 take away 2 is 3. Good job. Okay, my next number is going to be 15. 15 take away 2 is 13. Yes, good job. Okay, my last, not last, my final number in this series is going to be 25. So 25 take away 2 is 23. Did you see I had the exact same pattern that time? I just went up by 10 every time. So if you know 5 take away 2 is 3, then you know a lot of other facts too, right? Okay, this time we're going to take out 3, and my number to start is 6. So 6 take away 3 is 3. Good job. You probably knew that doubles fact, 3 plus 3. Okay, see if I have my pattern or it changes. 36 take away 3 is 33. Good job. Okay, my next number, we're still taking away 3, is 66. So 66 take away 3 is 63. Good job. So same thing. Now this time I went up by more than 10, but that didn't change the fact that if I knew 6 take away 3, I also knew 36 take away 3 and 66 take away 3, right? I was just going up by 30 instead of by 10. Okay. Last round, and this time we're going to take away 4, and maybe you've also noticed my pattern that I went up 1 each time in what we were taking away. See? Okay, and our first number is 7. So 7 take away 4 is 3. Good job. Okay, My next number is 77. So 77 take away 4 is 73. Good job. You're catching on to that pattern. Okay, last one. Don't let it intimidate you. We're still going to take out 4, and my number is 107. Oh my gosh. So 107 take away 4 is 103. It's kind of the same rate as 7 take away 4, just 100 more. Okay, good job. I hope your brain feels nice and warmed up for math. And we are going to, in the next video, talk about something a little bit of a new learning for us. I'm really excited. I can't wait to teach you guys. Okay, good job in your warm-up. See you in a minute.